Welcome on today's lesson. Our focus topic is geomorphology, and today we are going to focus on the principle of isostasy. Presentation objectives. After this presentation, learners should be able to define the principle of isostasy, applying different theories that explain this principle, demonstrate and understand of the main features of isostasy. Very important key concepts when discussing the principle of isostasy. Isostasy, the process of lithosphere crust sinking into the asthenosphere to keep the Earth's crust on an equilibrium position. Earth's crust. This is the outside layer of the Earth and is made of solid rock. There are two types of crust, oceanic and continental. Oceanic crust is denser and thinner, and continental crust is less denser and thicker. Lithosphere, the outermost solid layer of the Earth, composed of the crust and position of the solid upper mantle. Mantle, a layer inside the planetary body below the Earth's crust composed of the upper mantle and the lower mantle. Asthenosphere, a flexible plastic-like region of the upper mantle below the lithosphere. This is the structure of the Earth. Introduction of isostasy. Different relief features of varying magnitude. Example, mountains, plateaus, plains, lakes, sea, and ocean, and rift valleys standing on the Earth's surface are probably balanced by certain defined principles. Otherwise, they would have not been maintained their own form. Whenever the balance is disturbed, there starts violent earth movements and tectonic events. Therefore, isostasy simply means a mechanical stability between the upstanding parts and low-lying basin on a rotating Earth. What is isostasy? Isostasy is the adjustment of the Earth's crust in response to the pressure that is applied to it. Isostasy is when the Earth replies to the pressure that is applied to it, which causes the lithosphere to sink down and compress the asthenosphere. As we can see the picture, the lithosphere is sinking down towards the asthenosphere. The Earth's lithosphere and asthenosphere are very important when discussing the lithosphere. As we can see, this is the Earth layered structure. As we can see the lithosphere, the shape of the lithosphere, what happens to the shape of the lithosphere as pressure is applied, it sinks down the asthenosphere. Theories behind the principle of isostasy. The Airy's theory by Sir George Bernard Airy, Brett's theory by John Henry Brett, Haskell's theory by Veku Alexandri Haskell. These theories tried to explain the principle of isostasy. First, the Airy's theory of isostasy. According to his theory, the Earth's crust is like a rigid solid layer of lower density flowing on top of the molten layer of higher density beneath it. He stated that the crust has an equal density and unequal thickness. According to his theory, thicker parts of the crust, such as mountains, sink deeper into the underlying layer, asthenosphere, while the thinner parts of the crust, such as ocean floors, are floated up by it. Let's consider the example of Airy's theory explaining the principle of isostasy. Let's consider ice floating on water in which the greater part, the greater part of the ice is underwater, as the roots of the mountain beneath the lithosphere. The higher the ice rises above the water level, the deeper is the submerged portion. This supports that mountains have roots below surface that are much larger than their surface elevation beneath the lithosphere in the asthenosphere. This is the deeper submerged part of the ice. Moving to another theory, it's Spread's theory of isostasy. According to his theory, there is a difference in the density of the rocks in the Earth's crust and equal thickness below the sea level, the asthenosphere. In this theory, a mass above sea level mountains is supported below sea level, and there is a depth at which the total weight per unit area is equal across the Earth. This depth is known as the depth of compensation. He stated that Earth's crust of lesser density such as mountains has high elevation than to those of greater density like ocean floors. Let us look at his example. This diagram explains Spread's theory that states that the rocks blocks of lesser density project higher above sea level, shown as the inland bar, than to those of greater density, shown as the ocean floors at equal depth, known as the depth of compensation here. Depth of compensation, a boundary between the upper blocks and the lower dense blocks. Let's consider the last theory of Heiskannen's theory of isostasy. He compromised the two theories of Airy's theory and Spread's theory. In his theory, the average density of rocks of sea level is more than those at higher elevation, derived from Spread's hypothesis. According to his theory, those different rocks have different densities and according to extend downwards to different depths. This explains for the roots of mountains, derived from Airy's theory, and for the difference in densities in variation parts of the crust. This picture proves the Heiskannen's theorem, which combined the two theories. This picture advocates for Spread's theory with different blocks on the same depth of compensation, and this advocates for the Airy's theory with different blocks with different depth, the mountain roots. If a piece of crust loses some of its material due to erosion, it becomes lighter and floats higher in the mantle. When the eroded material gets deposited, the crust is weighed down, causing that area to sink lower into the mantle. A real example of isostasy in operation is seen in the Greenland, where the glacial ice compresses the crustal crust, which applies pressure in the mantle, which is the asthenosphere, and causes the weight of the glacial ice causes the mantle to sink down because of the mass of the ice cap. When the glacial ice melts, the crustal rock rebounds and rebounds to its normal shape, but this can take many years. Conclusion of the presentation. Having all the theories that try to explain the principle of isostasy, in conclusion, the theory of isostasy clearly explains the upwards and downwards vertical uplift of the mountain. Isostasy is the lithosphere and asthenosphere vertical movement of land to keep the Earth's crust balanced. Isostasy regulates the regional height of continents and ocean floors in relation to their underlying rock densities. Lastly, isostasy is the ideal theoretical balance of all substantial areas of the Earth's lithosphere as if they were floating on the denser underlying layer, the asthenosphere, a piece of the upper mantle made up of weak plastic rocks. This brings us to the end of our presentation. Thank you.